Okay, so we're gonna talk about my text mining project, opinion mining on the fitness industry. So as we know that fitness is kind of a very big topic and it's a highly debated topic. So I just wanted to take four labels basically consisting of fitness, steroid use in fitness industry, supplements, and nutrition in general. So and data science has already been applied to fitness industry in various ways, such as developing wearable fitness trackers and using big data to analyze consumer behavior, etc. And there has been a lot of sentiment analysis which was conducted in the fitness industry to see whether a supplement had a positive sentiment or whether a supplement had a negative sentiment towards it. And however, there is still much room for improvement in using data to understand the opinions and beliefs about the fitness industry, and this is where opinion mining comes in. By analyzing large volumes of text data from sources such as social media, Twitter API, news API, and stuff like that, we gain a better understanding of the sentiments and opinions of individuals and use this information to improve our opinion on the fitness industry or see what's exactly going on in the fitness industry. And so for data collection, I used Twitter API and News API, and they were categorized into four different labels and cleaned and formatted to my liking to conduct analysis. So let's see. And then if you go into clustering, and then we can see that the labels were categorized uh, based. So there were four labels. So I choose k equal to 4, and we can see that they are categorized pretty evenly. So they are differentiated well when we choose k equal to 4, and the optimal cluster is also at k equal to 4 or 5, something like that. And so if we go down for k equal to 5, then we see a decent amount of clustering, but k equal to 4 was the optimal one, and then k equal to 6, k equal to 7 is all it's not a good cluster behavior. So you can see that n equal to 4 cluster the best out of all clustering plots. This is also true because we have articles from four distinct categories in the fitness industry. So it would make sense that we would have four different distinct clusters, and this is hierarchical clustering. So this is using the cosine, sim, and average method for my dendrogram, and this is basically a subset of my data set. So it's not a huge data set, and this is all my code and all the things. So now let's look at the next thing, which is association rule mining. So in my association rule mining, so the most frequent word was anabolic. So it means anabolic steroids and then fitness. Then we have steroids, supplementation, nutrition, and stuff like that, health and all. So in here, so the top rules for support with that steroids are mostly related to anabolic, and then we have it's all like health is related to nutrition and nutrition is related to health, and it's stuff like that. So those are the top rules for support. And top rules for confidence is also very similar. So nutrition is related to health, health is related to fitness, and these are the most commonly occurring and uh, terms which have high confidence. So when it comes to interestingness, which is for left, we can see that the words fitness, health, nutrition, anabolic steroids have high association. So anabolic steroids, health, nutrition, they all have high association. So that's association rule mining. So basically what I assumed, like a fitness, health, and all these kinds of things have high association. Now let's look into LDA. So LDA is a topic modeling unsupervised machine learning algorithm. I used n equal to 4 primarily because I had four articles from four different topics. So I thought I could categorize them into four different topics and see how LDA performs. So topic 0, we can see that it's about fitness in general with steroid, anabolic, nutrition and all. For topic 1, we can see that it's a mix between steroids and supplements. And for topic 3, we can see it's all about nutrition and it's all about like food, nutrition, and stuff like that. And for topic and last topic, we can see that it's about supplements, like supplements, nutrition, filtered caffeine, workout, and stuff like that. And then that's LDA. So LDA results were pretty accurate, and I think LDA was gave me good results and helped me categorized my topics properly. Mm. And I found that LDA to be pretty useful and understand its applications in the real world and how it can be beneficial to data scientists and data analysts in general. So I noticed how words were organized into different categories if the data set had no labels and stuff like that. Topic modeling in general. Next, we come to NIBA supervised machine learning. So here we see I got an accuracy of 80.65, which is like pretty decent. And then we can see that the confusion matrix below uh, shows that fitness label shows the different labels. So fitness and anabolic steroids label were being predicted very accurately, and supplements and nutrition label were less accurate. From this, we can see that the nutrition label was generally getting mixed up with supplements. So that's assumed because they have a similar text or word structure. So that's what my naive based results were. And then let's go to decision trees. If you go to decision trees, it's very similar to I got a 75.48% accuracy. And then here also the results were similar. Fitness and anabolic steroids level were being predicted accurately, and supplements and nutrition label were less accurate. So here are a bunch of decision trees printed out. This is the entire tree. So this is with max depth 5 and this is with max depth 3. And the results were quite similar to with my naive Bayes too. And then let's look at support vector machines. And then support vector machines so I used three different kernels here with different cost accuracy, with different cost metrics. So for linear model, I got an 80% accuracy, which is pretty decent. And there's a similar structure here too. Supplements were getting mixed up with nutrition, and fitness and anabolic steroids are being predicted accurately. With the sigmoid kernel, I achieved like 79.35, which is also very decent. The same results, supplements and nutrition were getting mixed up. Fitness and anabolic steroids are being predicted accurately. And then with the RBF kernel, I got a 77.42% accuracy. The same results. Supplements and nutrition were getting mixed up. Fitness and anabolic steroids if you compare the kernels, this is it. That's good. So this is the decision boundary or the decision surface for the linear SVC. So I had to basically use linear discriminant analysis, which is a supervised dimensionality reduction system to, kind of reduce the dimensionality and plot this graph. And then this is when the SVM is this is the SVM viz when we reduce it to three features. So we can see that our hyperplane and how it, cuts between all the points, and we can see the support vectors here. So that's and then we come to neural networks, which is the final part of the final part of my project. So yeah, it's very simple. The results for my neural network model were good. An accuracy of 71% shows that it was performing decently on my data set. I used ReLU and Softmax as my activation functions, as well as categorical cross entropy as my loss function, and added two hidden layers for my classification algorithm because my data was divided into four different categories. So here we can see it running for a bunch of epochs and seeing the accuracy. So this is the training accuracy and this is the validation accuracy. It's roughly hovering up like between 70%. And here we see it being categorized into four different categories here. And we see some label overlaps here and some mismatched categories too. And this is the confusion matrix. So it's the same result again. So fitness and anabolic steroids are being categorized properly, whereas supplements and nutrition, not so much. So in the end, what I would say is, uh, to conclude this project, opinion mining on the fitness industry was it kind of gave me an insight into how fitness, anabolic steroids, uh, and nutrition and supplements together impact the fitness industry. And we see that nutrition and supplements are the most talked about things in the fitness industry. And we see and we see them often getting mixed up with each other. And when it comes to steroid use, in some of my visualizations, which is not included here in my EDA, I noticed that most of the people who were like into steroids were all people above 40 or stuff like that, because their testosterone levels drop significantly after they're 40. So that's what I saw in my viz, which is not here. And so that's it to conclude my project, and that's my project in a general 15-minute sense.